Is replacing the thermal paste on your GPU worth it? Well, some people say that it's basically regular maintenance, and other people say that it's too risky and that there isn't really anything to gain. However, the consensus seems to be that it might make sense if your GPU is a few years old. I do have a GPU that is a few years old. It's an RTX 2080, and I have been meaning to repaste it for quite a while, but I just haven't really gotten around to it yet. However, a few years ago, phase change thermal interface materials, specifically PTM 7950, started becoming popular in the PC building community. And supposedly those phase change materials are really good. Unfortunately, here in Europe it's quite difficult to get PTM 7950. So instead I got some of the recently released Thermal Grizzly PhaseSheet PTM to repaste my now almost 6 years old RTX 2080. So let's find out if it's actually worth it. This is Thermal Grizzly PhaseSheet PTM. It's a thermal pad, which according to conventional PC building wisdom would mean that it's worse than thermal paste. But because it is a phase change material, it changes from a solid state at room temperature to a liquid state at temperatures above 45 degrees Celsius. Apparently this gives it better performance than regular thermal pads, and according to one Tom's Hardware test, phase change thermal pads can actually outperform regular thermal pastes, only losing out to liquid metal, which is conductive and hard to work with. However, another one of their tests seems more realistic, so I wouldn't necessarily be so sure. Anyway, the part that's really cool about phase change thermal pads is actually their longevity. They're supposed to last longer without the kind of performance loss we normally see on thermal paste. Another pro, which is especially important when repasting a GPU, like I am doing in this video, is that it is easier to get perfect coverage of the die. On a CPU it doesn't really matter that much because of the heat spreader, which spreads out the heat, but on a bare GPU die it's quite important to get perfect coverage. Now, before you actually repaste your GPU, I would recommend that you find a teardown of your specific model, on YouTube for example, or one close to it maybe, so that you can see exactly how to take it apart and what to watch out for. But generally it's fairly easy. First, you have to remove the screws on the back. In this case, there are 6 of them. And then separate the cooler from the PCB, being careful of any cables. This can be a bit difficult depending on the current thermal paste application. We can now see that on my GPU, the original thermal paste did not look that great and had very bad coverage, especially on the right side of the die. Anyway, you then want to clean off the old thermal paste, both on the die and the heatsink, with something like isopropyl alcohol and a paper towel. They also make wipes specifically for this purpose, which might be a little bit easier to use. At this point you can cut the phase sheet to size. Thermal Grizzly recommends 2 to 3 millimeters larger than the die itself, and I can confirm that that's definitely a good idea, because lining it up is actually harder than it seems, so having a larger thermal pad definitely helps. To apply it, you peel off one side of the plastic first, put it on the GPU die, and then peel off the other side. Now, a tip that might be worth doing is putting the phase sheet in the fridge for some time before applying it, because that makes sure it's perfectly solid. Well, it's not perfectly solid, but it's solid enough and it's a bit easier to work with. Now, while the graphics card is disassembled, it might also be worth replacing your thermal pads. In my case, it didn't really make sense because the one exposed thermal pad was in great condition. But if they are ripped or cracked or dirty, it's probably a good idea. I did buy extra thermal pads, so I did replace it with a 1.5mm one from Arctic. I think that the stock one might have been slightly thicker, but definitely not 2mm, so the 1.5mm was the closest one I had. And it's important to get the right thickness, because otherwise you don't really make perfect contact. In my case, there were also some thermal pads on the memory modules, but they were under a second metal plate and I didn't want to remove it. Especially because the memory doesn't have temperature sensors, so I wouldn't know if I did something wrong and their temperature climbed significantly. So I only replaced the thermal pad for the VRMs, which is the one that's exposed on this 2080 model. Anyway, after you've done this, it's time to reassemble the graphics card. Now, when you screw it back together, you should do it in a kind of star pattern to evenly distribute pressure. So now that the GPU is done, it's time to show you the results. But before I do that, there is one small disclaimer. Some time ago, I replaced the fans on the graphics card with ones from Noctua to lower the noise levels. And they did lower the noise levels. And actually, let me know if you want to see a video of this. However, I don't know how the fans impact the cooling performance. So because of that, the actual results won't be directly comparable, even if you have the exact same model of RTX 2080 in an RG Strix model. So just be mindful of that. But it doesn't really matter that much, since we are testing the thermal interface material and not the fans or the heatsink. Now, because of that, I have also set the fans to 100% for all the tests to place the bottleneck on the thermal interface material as much as possible and not the heatsink. Now, with that out of the way, let's get to the results. In Furmark, there's a significant difference in GPU temperatures, around 8 to 9 degrees. However, on the hotspot temperature, we can really see a huge improvement. On the original thermal paste, it reached over 107 degrees. That's a delta of over 35 degrees. While with the phase sheet, the temperature is around a much more manageable 75 degrees. And that's a delta of 11 degrees, which is much more in line with what it should be. Already this is great, but if you look at power consumption, these figures are even more impressive. With the phase sheet, the GPU uses 70 watts more power, and not only this, the core clocks are about 100 MHz higher. All of this is great, however, there is one area that actually became worse after the upgrade, and that is VRM temperatures. The VRM temperatures are around 6 degrees higher with the phase sheet and the Arctic thermal pad. Now, at first I thought that this was because the Arctic thermal pad might be slightly thinner, so it doesn't make as good contact as the original pad, but I don't think that's actually the case. Remember that the GPU uses 70 watts more power now. This power goes through the VRMs, which then get hotter. The GPU also has to dissipate more heat now, which goes into the heatsink that also gets hotter and therefore can't cool the VRMs that well. So even though the number is technically worse, that doesn't necessarily mean that it's because of the new thermal pads. Now, because the Furmark test showed a promising uplift in power and core clocks, I was excited to see if there was an uplift in 3D Mark as well. And there was. Before, with the almost 60-year-old thermal paste, the score was around 9200, which is worse than an RTX 2080 should be able to achieve. And with the phase sheet, the score was 1100 points higher at around 10,300, which is more in line with the average. I don't really have good temperature readings because the test also includes loading screens and the CPU test, but the max temperature on the original thermal paste reached over 107 degrees again, while with the phase sheet it never even reached 68. This means that there probably is some overclocking headroom left, maybe? I was also curious how these results would translate to actual gaming. So I used the benchmark mode in F124 because it allows for relatively long benchmarks. For example, the one I used was 10 minutes. I used maximum settings with ray tracing to place as much load on the GPU as possible. And here are the results. For temperatures, it's generally the same story as before, just slightly better. But this is because the power consumption is actually lower in F124 and the difference in core clocks isn't that high. However, the benchmark did report significant improvements to FPS, with a 5 FPS increase in both average and minimum numbers. At these FPS levels, that does actually make a difference. Now, so far I've been testing with the fans at full speed, but I would never actually game like this. So I also ran a test with the fans set to 30%, which resulted in a much more reasonable noise level. I wanted to see whether the phase sheet wouldn't see as much of an improvement over the original thermal paste when the temperature delta between the GPU die and the heatsink wasn't as high. But it turns out that the improvement was actually bigger. Maybe not in the temperatures themselves, but with the original thermal paste, the GPU had significant thermal throttling, with both lower power and core clocks. With the phase sheet, the core clocks were slightly lower, with the lower fan speed, but the power consumption was actually higher. I know that this seems weird, but I ran the test again, and the results were the same. Now, I'm not sure why this is, but the FPS numbers ended up going from unplayable with the original thermal paste to reasonable with the phase sheet. Not only that, these numbers are identical to when the fans were spinning at full speed, meaning that there wasn't any real performance loss with a lower fan speed with the phase sheet, which I see as a huge win. Overall, I'm really happy with these results, but there is one more graph that I want to show you. Thermal Grizzly says that the phase sheet reaches maximum performance after 10 heat cycles over 60 degrees. So, before I ran the actual test, I ran the Furmark test 10 times, and here are the results. As you can see, there wasn't really a difference, all within margin of error really. And this could be because the real difference is too small to actually see, or it could also be that my thermal cycles weren't long enough. The Furmark test was only 10 minutes after all. But in both cases it means that it either isn't necessary or practical to go out of your way to actually run these thermal cycles before you test if the phase sheet has made an improvement on your GPU. If you of course decide that it's worth it for you. But has it been worth it? Well, for me, it definitely has, at least so far. As I said, my RTX 2080 is almost 6 years old, and it has seen a lot of use. But the results almost speak for themselves. The improvement both to thermals and performance are really good, and it breathes a bit of life into what otherwise felt as a bit of an aging card. So if you have GPU of a similar age, and maybe especially if you're seeing as high hotspot temperatures like I was, it could be worth a try. The only thing that's left now is to see whether the phase sheet keeps its performance over a longer period of time. I'm probably going to test that and probably make a video about it, maybe in 6 months or a year. And if you're watching this in the future, there's going to be a link to it right here. Otherwise, you can subscribe so that you don't miss it. But that was it for this video. Thanks for watching, and I'll see you in the next one.